We are ready to finish up our chapter now by seeing what happens when you get a cut and how you stop bleeding. So we're going to talk about hemostasis. Heme refers to blood, and stasis means stand still. So this just means that you stop bleeding. And in the last one, I mentioned agglutination, and not to confuse agglutination with coagulation. Coagulation is a part of hemostasis. Coagulation means you form a blood clot. So first we're going to look at an overview of hemostasis and what happens. So we're going to begin here with number one is you have damage to your blood vessel. You have a cut and you are bleeding. The walls of the blood vessels contain collagen fibers. So there is collagen fibers here in the walls of your blood vessel. As long as your blood vessel is intact, those collagen fibers stay inside, right? Nothing is contacting them. The walls of the blood vessel are very smooth and slick. So out here, it is very smooth and slick. But when you get a cut, those collagen fibers are exposed. And this is going to be key because this is what the platelets stick to. Okay, so you have a cut, collagen fibers are exposed. The first response your body has to this is vascular spasm. So now these next set of pictures are your responses to the cut. So we're going to have vascular spasm. You can see here the blood vessel is constricting. It does this to reduce the amount of blood being lost through the cut. Next is when those exposed collagen fibers come into play. This is platelet plug. Platelets are flowing in your blood, so you constantly have platelets flowing around as part of your blood. When there's exposed collagen fibers, the platelets stick to them. Then the last thing that happens is coagulation. You form a clot. And then this clot plugs up that hole, and then you're no longer bleeding. And then you can begin the healing process. So we're going to look more at the blood clot and how that forms. First of all, let's look at the composition of a blood clot. Here is the clot. A blood clot is a web of fibrin with formed elements trapped inside. So if we look closely at this, you can kind of see this web, these strings here. This is a protein called fibrin. Kind of makes me think, remember the Spider-Man movie where there was the Spider-Man and there was that black gel that would get on him and it would grow on him and make a web on him? That's what this reminds me of. So a clot is a web of fibrin, which fibrin is a protein, and it traps formed elements, like bugs getting trapped in a spider web. And if you remember from the very opening of this chapter, formed elements are the red blood cells, white blood cells, and platelets. So all three of those, if you look in here, there's red blood cells and platelets, and maybe a few white blood cells get trapped in there. So that is your clot. So now we need to see how you get to the clot. So notice you have all these things here, these factors. If you look along, you've got factors everywhere. Think of this like a chain of dominoes. If we have dominoes, and you know how you knock down the first domino, and that makes all the others fall. That's how coagulation works. We're going to start off here with a cut, and we're going to end here with a blood clot. These dominoes are factors. Factors are proteins that are in your blood. And they are made by your liver. And they're inactive. So like just when these dominoes are standing up, they're inactive. Or sometimes you can think of it like having a can of SpaghettiOs in your kitchen cabinet. It's inactive. It's there when you need it. So that's what the factors are like. They're these proteins that are made by your liver, they're put in your blood, and they're inactive. And they're just flowing around as part of your blood. When you get a cut, you activate the first one. Well, that's like knocking down the first domino. And that activates the next, which activates the next, which activates the next, and so on. So that's what you see going on here. Here you have all these factors activating the next. You begin here, you have your platelets. They activate factor 12, which activates factor 11, which activates factor 9, which activates 8, which activates factor 10. Notice also along the way you have calcium sprinkled in here. If you remember back in chapter 7 when we were talking about blood calcium, and we said that one of the reasons you need blood calcium is in order to form blood clots. So also along the way here you have calcium is needed in order for some of these dominoes to each knock down the next. So you have these factors from your liver. When you get a cut, they begin activating each other. So a cut, the factors activate each other. Okay, when you get to the end here, the last couple of them are thrombin and fibrin. So the last domino is going to be fibrin, because this is the web that catches the formed elements. And the one that activates fibrin is thrombin. So you get through all your factors. You have prothrombin activated to thrombin. So its name is prothrombin when it's inactive. Its name is thrombin once it's been activated. So you can think of it like When the domino is standing up, it is prothrombin, and then when the domino falls down, it is thrombin. Okay, then you have fibrinogen. So when the domino is inactive and it's standing up, it's fibrinogen. And then when thrombin knocks it down and it's active, it is called fibrin. So prothrombin and fibrinogen are the inactive forms. Thrombin and fibrin are active. Thrombin is what activates fibrin. So you go through your factors. Factor 10 activates prothrombin activator, which turns prothrombin into thrombin. Thrombin then turns fibrinogen into fibrin. Fibrin forms a web, catches the formed elements, and you get a clot. So that's that whole chain reaction to make a clot. And remember that you need calcium in the blood in order for this chain of dominoes to work. Okay. Once scientists understood how this worked, then they can figure out ways to manipulate it. So sometimes you don't want a clot. Some people have problems with clotting. Okay, you can get unwanted clots. Ideally, they just form when you get a cut and you need it in order to stop bleeding. But you can get unwanted clots. And unwanted clots can cause stroke. They can cause heart attack. Because the clot can form, it can break loose, and then it can get stuck somewhere else in the blood supply, and it's going to block off blood to part of the body. So a stroke is when you block the blood to the brain. And a heart attack would be blocking blood to a part of the heart. So people who are at high risk for these conditions can take medicines to reduce their ability to make blood clots. Okay, so Coumadin is a common one, and it's also warfarin is the actual chemical, Coumadin is the brand name. This is a very commonly used anti-clotting medication, and it acts on the liver. So remember those factors. You need those factors. Those are the proteins in your blood that activate the thrombin, which then activates the fibrin. And remember that factors are made by your liver. Well, in order to make factors, your liver uses vitamin K. So the way Coumadin works is this medicine blocks vitamin K from the liver. So if you're on Coumadin, vitamin K cannot get into your liver. And if your liver can't get vitamin K, it can't make the factors. And then if you don't have factors, you can't activate thrombin, you can't activate fibrin, and you can't make a blood clot. Another common one is aspirin. If we look back up here, notice the platelets are what activate the first factor. So that's kind of the very first thing here in our chain of dominoes, is the platelets activate the first factor. Aspirin blocks this. Aspirin acts on platelets, and it stops the platelets from activating the first factor. It stops platelets from secreting chemicals. And these chemicals, what they normally do is attract more platelets, so platelets stick to each other once they're active, and they activate the factor. So it stops the platelets from secreting chemicals that would cause the platelets to stick together and activate the factors. So back up here in the coagulation process, if you take aspirin, you stop that first domino from even being knocked down. And if you take warfarin, you don't have the dominoes. They're not there to be knocked down.